All right, so section 11.4 talks about tree diagrams. Let's see if I get this pen to work. Let's see. Oh, come on. Pause this, guys. Sorry about that. Okay. So 11.4 talks about tree diagrams. And the first thing we have here is something called the counting principle. It says if a first experiment can be performed in m distinct ways, excuse me, and a second experiment can be performed in n distinct ways, then the two experiments in that specific order can be performed in m times n distinct ways. All right. So let's take a look at the first problem and see if we can't figure this out. Let's see. So it says here, a radio station has 2 tickets to give away to a Blake Shelton concert. It held a contest and narrowed the possible recipients down to 4 people: Christine, Mike, Larry, and Phyllis. The names of 2 of these 4 people will be selected at random from a hat, and the 2 people will be awarded the tickets. Okay, so it says use the counting principle to determine the number of sample points in the sample space. Okay, so let's figure out what they mean by this. So we have 4 people, right? We're going to rank them as Christine. Why is that not working again? Sorry about that, guys. Here we go. Okay, so we have Christine, we have Mike, we have Larry, and we have Phyllis, okay? And they're going to give away 2 tickets. So the first time they do their drawing, they can pick from 4 people, okay? Now, that's giving the first ticket. Now, when they give the second ticket, now there's only 3 people to choose from. So what we mean is we have a total of 12 possible outcomes here, okay? That's the number of sample points in our sample space. Now, part B says draw a tree diagram, okay? So our tree diagram is going to look something like this. The first time we choose, we can choose either Christine, Mike, Larry, or Phyllis. Now, I want you to think about something. Suppose we have already chose Christine. Well, if we've already chose Christine, then the second time we do this, we can only choose from Mike, Larry, or Phyllis. If we choose Mike the first time, then we can only choose now from Christine, Larry, and Phyllis. If we choose Larry the first time, then we can only choose from Christine, Mike, and Phyllis. And if we choose Phyllis the first time, then we can only choose from Christine, Mike, and Larry. Okay? That's what we call a tree diagram. Okay? This gives us all the 12 possibilities. Okay? So now, we're going to take a look, see if we can't figure this thing out. So, part C. Part C says, determine the probability that Christine is selected. Okay, well, we know we have a total of 12 choices. Okay, we're going to find all the ones that have Christine. So, Christine and Mike, Christine and Larry, Christine and Phyllis, that's 3 of them. Mike and Christine, that's 4. Larry and Christine, that's 5. Phyllis and Christine, that's 6. So the probability that Christine is going to be selected is 6 out of 12, which is the same thing as 1/2. Okay? Now, let's take a look at this, and that. Okay. Let's take a look at part D. Part D says, determine the probability that Christine is selected and then Mike is selected. So, come back to our probability. Okay, we have 12 options. First, we want Christine, and then we want Mike. Well, here's Christine, and there's Mike. There is only one of them that looks like that. So, 1 out of the 12, okay? So, what I like about the tree diagram, guys, it's visual. I can see exactly what's going on. I mean, obviously it gets a little messy. I'm going to try to do a little better job drawing my tree diagram on the next problem. But it's visual. I can see what's going on, okay? All right. So, let's take a look at the next one we have here. And it says, at Finley's restaurant, Each lunch special consists of a sandwich, a salad, and a beverage. The sandwich choices are roast beef, ham, or turkey. Salad choices are macaroni or potato. Beverage choices are coffee or soda. Okay, so it says Part A, using the counting principle, determine the number of different lunch specials offered by the restaurant. Sandwich choices, roast beef, ham, or turkey. We have 3 of them. Okay. Salad choices, macaroni or potato. We have 2 of them. Beverage choices are coffee or soda. We also have 2 of those. All we're going to do now is multiply straight across. 3 times 2 is 6, times 2 is 12. Okay. Now, Part B says, construct a tree diagram and list the sample space. Okay, so I'm going to try to do this as best as I can. So we can either choose a roast beef sandwich, a ham sandwich, or a turkey sandwich. Okay. Then when we go with our salad choices, we can either get potato salad or macaroni salad, potato salad or macaroni salad, okay. Potato salad or macaroni salad. And then when we choose our beverage, we can either choose coffee or soda. For each one, coffee or soda. Okay. This is why we call it a tree diagram, because it looks like little branches of a tree. Okay. Coffee or soda. All right, so there is my tree diagram. I'm going to kind of scroll it down just so I can see a little bit better and do Part C. So Part C says, if a customer randomly selects one of the lunch specials, determine the probability that a roast beef sandwich and a soda are selected. Okay, so for Part C, again, we know we have a total of 12 options. We want them to have a roast beef sandwich and a soda. Okay, a roast beef sandwich and a soda. So a roast beef sandwich, they can get potato salad and a soda, or they can get a roast beef sandwich, macaroni salad, and a soda. So there's 2 options here. So 2 out of the 12 would give me the same thing as 1 out of 6. Okay. Now, Part D says, if a customer randomly selects one of the lunch specials, determine the probability that neither macaroni salad nor coffee is selected. Okay, so we don't want macaroni salad and we don't want coffee. So I'm going to get rid of this whole branch here and this whole branch here and this whole branch here, because those have macaroni salad. Okay? And then we don't want coffee, so we'll get rid of the coffee ones. Right? Boom and boom. Okay, so we can get a roast beef sandwich, potato salad and a soda, a ham sandwich, potato salad and a soda, turkey sandwich, potato salad and a soda. That's 3 options that we have. 3 out of the 12 would give me 4th, right? So guys, notice when we took away the macaroni salad, we're taking away that whole thing, right? That whole piece of it. Okay? Because it has macaroni salad. We don't want that at all. Okay? Alrighty. Let's take a look at the next problem here. It says 2 balls are to be selected with replacement from a bag that contains 1 red, 1 blue, 1 green, and 1 orange ball. Okay. So it says one of the balls is going to be red. Okay. So there's a red ball. Okay. Let's see. 1 red, 1 blue. So one of them is going to be blue. Let's go with this one here. There's blue. One of them is green. Here's green. And one of them is, what did it say, yellow? Oh, 1 orange ball. Okay. Orange ball. Where's orange? Here we go. Okay. So 1 red, 1 blue, 1 green, 1 orange. Okay. So now let's come back, and it says we're going to select 2 balls from here, okay? And we're going to replace it. So what does that mean? The first time we choose one of these, we have 4 choices, okay? But whatever ball we selected, we put it back. So the second time I choose, I still have 4 choices, okay? So that tells me we have a total of 16 options here, okay? Now, we're going to do our tree diagram. Okay, so we have 4 options the first time. Okay, so we can pick either red, blue, green, or orange. And then the next time we do this, we still have 4 choices. We can still pick red, blue, green, or orange. Red, blue, green, or orange. Red, blue, green, or orange. Red, blue, green, or orange, right? Okay. So now let's take a look. Let's come back here and let's go, I don't know, let's go with red. Okay. So that was part B. Let's take a look at part C. Part C says, determine the probability that the red ball is selected twice. So notice we have a total of 16 options here. The only time the red ball is selected twice, if the first one is red and the second one is red, that's only one option out of those 16, okay? Okay, part D now says, determine the probability that neither ball is orange. So I'm going to get rid of that one right there, that one right there, that one right there. Neither ball is orange, so I don't want a single orange ball. I'm going to get rid of that whole thing. So notice we have 3, 3, 3. That's 9 out of the 16. And then part E says, determine the probability that the orange ball is selected at least once. Okay, the orange ball is selected at least once. Okay, so there's 1 option here, 2 options here, 3 options here, and then 4, 5, 6, 7 options there. So 7 out of the 16. Okay. All right. So now I'm going to scroll down to the next part. Take a look what we have here. It says the probability of an event happening at least once. It says the probability of it happening at least once is equal to 1 minus the probability that it does not happen. So when we did part C, neither of them are orange. We got 9 out of the 16. So 9 out of the 16 is going to give us at least, that none of them are going to be orange. Well, what's the probability that at least one of them would be? The rest. 9, so there's 9 out of 16. How many are left over? 7 of them are left over, okay? So let's take a look at the next problem that we have here. Boys and girls. And it says a couple plans to have 2 children. Determine the number of sample points in the sample space of possible arrangements for boys and girls. Okay, so the first time we have a child, it can be either a boy or a girl. The second time we have a child, it can be a boy or girl. So we have 2 options the first time, 2 options the second time. So we have a total of 4. Okay. Part B says, let's draw our tree diagram. Okay, so the first time we have a child, it can be a boy or it can be a girl. Second time we have our child, it can be a boy or a girl. Okay. All right. Okay, so now let's start answering our questions. Assuming that boys and girls are equally likely, determine the probability that the couple has 2 girls. Okay, so we want to have 2 girls. 1, 2, here we go. So out of the 4 possibilities, one of them gives us 2 girls. Okay? So guys, one thing I want to mention right here, actually I forgot to do this on the other one, it says to list the sample space. So what we mean by the sample space, let me write it out. We could have a boy and a boy. We could have a boy and a girl. We could have a girl and then a boy. Or our first child could be a girl and the second child could be a girl. So this is what my sample space looks like, okay? So you can see out of the 4 options, 2 girls, there's 1 of them, right? Okay. Now look at part D. Part D says at least 1 girl. Okay, well there's 4. How many of them have at least 1 girl? That one has at least 1 girl. That one has at least 1 girl. That one has at least 1. At least 1 means 1 or more. So 3 out of the 4. Okay. Then part E says a girl and then a boy. Well, that's this one right here, because it says a girl, then a boy. So there's only one of them like that. And then part F says no girls. Well, there's only one that has no girls, and that's that one right there. So 1 out of the 4, okay? All right. Taking a look at the next problem. It says a bag contains 5 batteries, all the same size and equally likely to be selected. Each battery is a different brand. If you select 3 batteries at random, using the counting principle, determine how many points will be in the sample space if the batteries are to be selected with replacement or without replacement. Okay, so we're going to have three batteries, or 5 batteries, okay? So battery 1, 2, 3, 4, and 5, okay? Now, we're going to select 3 of them, okay? The first part says with replacement. Okay, so I'm going to choose one of these. So I have 5 choices, okay? But whichever one I pick, I'm going to put it back in there. So the second time I pick, I can still pick 5, and whichever one I pick, I'm going to throw it back in there, and I'm going to do this again. So if I multiply straight across, that'll give me 125. Now, look at what without replacement means. So without replacement means I'm going to take one of these batteries, okay? How many batteries can I choose from? 5. But I'm not going to replace it. Oops. That means now I only have 4 to choose from, okay? And I'm going to take that one. Now I only have 3 to choose from, okay? So we're going to multiply straight across. 5 times 4 is 20, times 3 gives me 60, okay? So there's a difference in with replacement and without replacement. Okay. Alrighty. Let's take a look. Bonsai trees. So Selby Garden sells bonsai trees. Customers can choose juniper, maple, fir, or boxwood bonsai tree. They can also pick a circular, oval, or square base. The Chens are going to select one of the bonsai trees and one of the bases at random. Okay, determine the number of sample points in the space. So let's see, we have juniper, maple, fir, and boxwood. So we have a total of 4 trees. Circular, oval, or square base. Have a total of 3 bases. So we're going to have 4 times 3. We have 12 options. Okay. Part B says, let's do a tree diagram. Okay. So 1, 2, 3, and 4. We can pick juniper, maple, fir, or boxwood. Okay. And then we can pick 1, 2, 3, circular, oval, square. 2, 3, circular, oval, square. 3, circular, oval, square. 1, 2, 3, circular, oval, square. Okay, so guys, I'm going to go ahead and write out, list the sample space, okay, because that's what this piece says right here. All that means is we can get a juniper tree with circular, juniper tree with oval, juniper tree with square. Maple with circular, maple with oval, maple with square, fir tree with circular, fir tree with oval, fir tree with square, and let's see, boxwood, circular, boxwood oval, boxwood square. Okay. All right, now let's take a look at the next piece here, and it says determine the probability that they select the juniper tree. Okay, 12. How many of these have a juniper tree? Those 3. 3 out of 12, same thing as 1/4. Okay. All right. Part D, total of 12. The maple tree and the square base. Well, there's only one of them. Okay. Part E, a tree other than the boxwood. So if I don't want these 1, 2, 3, how many are left over? 9, right? 9 out of the 12, divide them both by 3, 3/4. Okay. All right, let me scroll down and let's take a look at the next problem here. Okay, so it says from the list below, Steve will purchase 1 appetizer, 1 beverage, and 1 dessert. Dessert. Hello. Sorry, guys. Guess I'm a little tired today. To bring to a party. Okay, so let's see. How many appetizers do we choose from? We have 2. Beverages, we have 2. Desserts, just kidding. Desserts, we have 3. So 2 times 2 is 4, times 3 we have a total of 12. Okay. All right, so now what we're going to do, we're going to draw our tree diagram, okay? So we can pick either a vegetable tray or guacamole, and then we can pick either soda or lemonade, and then we can pick after that either pie, brownies, or cake. Pie, brownies, or cake. Okay, there we go. Okay, so then, same thing here, guys. My sample space, vegetable tray, soda, pie, vegetable tray, soda, brownies, vegetable tray, soda, cake, vegetable tray, lemonade pie, vegetable tray, lemonade brownie, vegetable tray, lemonade cake, guacamole, soda pie, guacamole, soda brownie, guacamole, soda cake, guacamole, lemonade pie, guacamole, lemonade brownie, guacamole, lemonade cake. Okay. All right. Let's see. Okay. So, determine the probability that Steve selects guacamole. Okay. Well, guys, if you look here, this thing is cut right in half, right? How many of them are here? Half of the 12, which is 6. That's half. Okay. Lemonade and brownies. So lemonade and brownies, out of the 12, let's see, here's a lemonade and brownies, here's a lemonade and brownies, so 2 out of the 12, which is 1/6, and then a dessert other than pie. Okay, so we don't want any pie, so let me do that. Okay, so let's get rid of the ones that have pie. So I'm getting rid. So out of the 12, we got rid of 4, so there should still be 8 left. 8 out of 12, if I divide those both by 4, that gives me 2/3, right? Guys, one thing I want to mention when you're doing this in my math lab, these, at least the first part of the question is going to be multiple choice. You just got to choose the right one, okay? All right, so that was 11.4.